ప్రాబబిలిటీ డిస్ట్రిబ్యూషన్ ఫంక్షన్ గురించి ఎక్స్ప్లెయిన్ చేస్తాను. Probability distribution function. It describes the behavior of the probability. We know that probability means number of favorable outcomes to total number of outcomes. Number of favorable outcomes to total number of outcomes. Total number of outcomes. This is the probability. But PDF, probability distribution function, is denoted with capital F of x only, capital F of x, and it describes the behavior of the random variable x probability. I'll explain clearly. Here you can see this. If you toss a coin and probability to get head is head or tail. Probability to get head is, that is favorable outcome. Only one chance is there, one chance out of two chances. So, and probability to get tail is only one favorable outcome out of two favors. So this is the case. Here, if you are assigned the outcomes, probability to get head outcome, probability to get tail outcome, this is the probability of random variable x if you are assumed. So if you are assigned real numbers to these outcomes, then it is called as, that is random variable. And here this is the probability behavior of this experiment. The cumulative addition of all probabilities is called as, that is probability distribution function, denoted with f of x. Cumulative addition means, that is 1 by 2 plus previous probability is 0 here. This is the distribution at random variable 1 outcome. And similarly, this is at this point, at the outcome of 2 is, that is present probability 1 by 2 plus previous probability is 1 by 2. So this is equal 1. This is equal 1. So if we represent graphically the distribution function, so capital PDF f of x. So here at 1, what is the distribution? 1 by 2 only. At 1, 1 by 2. At 1, 1 by 2. At 2, second outcome, for second outcome, what is the PDF? 1. What is the PDF is 1. So here it is 1. So this is the distribution function. This is the distribution function. Graphically, we can, if you are defined graphically, then it is called as probability distribution function, denoted with capital F of x. F of x is equal probability of x less than or equal to x. If you consider, this is the mathematical equivalent. If you consider here fx of 1, first outcome, that is equal p of x less than or equal to 1. This is equal, what is x less than 1? Only one outcome, only one is there here. So that's why the corresponding probability is how much here? How much? That is 1 by 2 only. 1 by 2. 1 by 2. Plus there is no previous. Less than 1, there is no 1. So similarly, fx of 2 is equal probability of x less than or equal to 2. Means what is the less than 2 values in random variable outcome? Fx x equal to 1 plus probability of x equal to 2, less than or equal. So one value is 1 by 2 plus 2 value is at probability 1 by 2 is equal 1. So this is the mathematical representation for the probability distribution function. It is also a probability only, but it describes graphical representation. Then it is called as, that is probability distribution function. I will show you one more example. Here you can say this PDF. If random variable x is having, that is 1 2 3 4, 1 2 3 4, and here the corresponding probabilities are p of x is equal 0.2, 0.3 and 0.3 and 0.4, 0.2. So total probability should be equal to, always should be equal to 1, as you know that. Here this is the probabilities. Then what is the PDF, capital PDF probability distribution function? Present probability 0.2, present probability is 0.3 plus 0.2, that is equal 0.5, and present probability 0.3, 0.3 plus previous is 0.3 plus 0.2, total 0.6, 0.8. Similarly, present probability 0.2 plus 0.3 plus 0.3 plus 0.2, that is totally it is 1. This is the PDF. In one line we can explain, but if you want to calculate using mathematical equivalent, so we can write it as fx of x PDF is equal probability of x less than or equal to x. So if you want the first value fx of 1, so therefore p of x less than 1, x less than 1 value is only 1 only, that is corresponding probability is how much it is. Here you can say this 0.2, so only 0.2 only in the first case. And fx of 2, here fx of 2 means that is probability of x less than or equal to 2, x less than or equal to 2. Therefore x less than 2 values are x equal to 1 is less than or plus f of x equal to 2, x equal to 2. Therefore x equal to 1 values are 0.2 plus x equal to 2 values is how much? Probability of x equal to 2, probability is 0.3, this is 0.3, so therefore this is equal 0.5, this is equal. Like this we need to calculate the probabilities. PDF p of x less than or equal to 3 means that is p of x equal to 1, less than 3 values are x equal to 1 plus and x equal to 2 plus, and 3 value also can include, that is probability of x equal to 3. So therefore this is equal 0.2 plus 0.3 plus 0.3 is equal 0.8. Like this we can calculate the PDF. And so this is about PDF probability distribution function, and this is the density function, probability density. Thank you.